All right. Now getting into multiplying radical expressions. So when it comes to multiplying, the terms do not need to be the same to combine. So something like the square root of 2 times the square root of 3, that does equal the square root of 6 because 2 times 3 is 6. So unlike adding and subtracting, if two radical expressions have different radicands, we can do the arithmetic kind of how your brain already knows how it works. So the biggest thing to remember with multiplying is that you always do whole times whole or coefficient times coefficient and radical times radical. That's how we combine them. So if I look at A, I have 4 times the square root of 8 times the square root of 10. So I have 4 times this unwritten 1 here, so that gets me 4. And then I can do the square root of 8 times 10, which is 80. So now I need to think, can I simplify down the square root of 80? And I can. I know 80 is 16 times 5. And I know that the square root of 16 is 4. So when I move that out, I get that that is 4 times the square root of 5. So when I get my final answer, 4 times 4 is 16. And then left inside of my square root is 5. If I go to B, this is a monomial times a binomial, so I need to distribute this monomial to both terms in the binomial. So I have 5 radical 2 times 3. 5 times 3 is going to get me 15. And then since there's no radical term with the 3, that's just going to be the square root of 2. And then I need to also then distribute it to the 4 radical 2. So I have 5 times 4 is equal to 20. And then the square root of 2 times the square root of 2 is the square root of 4. And we know that the square root of 4 is equal to 2. So this is really 15 times the square root of 2 plus 20 times 2, which we know is 40. So I have 15 times the square root of 2 plus 40. And we know that by adding and subtracting, we can't combine them because they are not considered like terms. So this is my answer in simplest radical form. If I go on to C, I have a binomial times a binomial. So basically think we need to FOIL this out. So I have negative 2 times the square root of 5x times the square root of 10. So that's going to get me negative 2, and then 5x times 10 is the square root of 50x. Going on to my next two, negative 2 times positive 2 is minus 4. The square root of 5x times the square root of 3x is going to be the square root of 15x squared. My inner 2 times the square root of 10, those can't be combined, so it's just multiplied 2 radical 10. And then my final 2 times the square root of 3x is going to get me 4 times the square root of 3x when I multiply that. Now looking at all these, I need to ask, can I simplify individually? So if I look at my first one, the square root of 50x, 50 is 25 times 2. So I know that I can move that 25 out. So I have negative 2 times 5 is equal to negative 10 times the square root of 2x. If I look at my second term in green, the square root of 15x squared, I can't simplify 15, but I can simplify the x squared. That gets me 1 whole x. So this is minus 4x times the square root of 15. And then I have the 2 times the square root of 10. That cannot be simplified down. 4 times the square root of 3x also can't be simplified down. So if I take a look, I can't combine anything. So this is the final answer in simplest radical form. All right, if I go ahead on to my last one, whole times whole. So negative 4 times 3 is negative 12. And then I have the cube root of 25 times 15 is 375. So now I need to ask myself, what are the perfect cube factors of 375? The biggest one I get is 125. So I have negative 12 times the cube root of 125 times 3. And I know this cube root of 125 is 5. So again, this is negative 12 times 5 times the cube root of 3. And so when I go, I multiply. So negative 12 times 5 gets me my final answer of negative 60 times the cube root of 3. So again, with multiplying, just remember you can combine even when they're not the same. Okay, so that brings us to rationalizing the denominator. So by definition, what it means is to move the radical term to the numerator so that the denominator becomes a whole number. So from here on out, we will always be rationalizing the denominator. So if you ever get a solution and you have a radical term in the denominator, you need to get it out by using this method of rationalizing. So in the first example, I have just one single radical term in my denominator. So when you have something like this, you're going to multiply both the numerator and denominator by whatever that radical term is. So since I have 7 times the square root of 2 divided by the square root of 7, I'm going to multiply both the numerator and denominator by the square root of 7, because this is basically just multiplying it by 1. And then I'm going to multiply across numerator times numerator, denominator times denominator. So in my numerator, I have 7 times the square root of 14. And then the square root of 7 times the square root of 7 is just 7. And now I take a look. I ask, can I simplify down? And I see that the 7s can cancel. So my final simplified answer is the square root of 14. If I look at B is different because I have a full expression. So when you have a full expression, you're going to multiply by the conjugate of whatever is in the denominator. The conjugate of a radical expression is just where the radical term flips signs. So if I had something like 2 minus the square root of 2, its conjugate is 2 plus the square root of 2. So again, the radical sign is always just going to change. So in B, I have 4 divided by 5 plus the square root of 5. So to start simplifying that, I need to multiply both the numerator and denominator by the conjugate of 5 plus the square root of 5, which is 5 minus the square root of 5. And now I'm going to go ahead and multiply. So 4 times 5 is 20. 4 times the square root of 5 gets me 4 times the square root of 5. And now if I look in my denominator, I have a binomial times a binomial, which is, we know, foiling. But if you kind of remember when we worked with imaginary numbers, we were multiplying by the conjugate when we divided complex numbers by one another. And so we got always the same answer of a squared minus b squared. When you multiply by the conjugate here, you're going to get always the same answer of a squared minus the square root of b, or whatever the nth root is, squared. So I'm going to FOIL this out just to show you how this works. But then from there on out, I'm just going to always work with that fact. So when I go ahead and FOIL, I get 5 times 5 is 25. 5 times the negative square root of 5. 5 plus the square root of 5. And then square root of 5 times the negative square root of 5 is minus 5. So if I look at these middle two terms, they are going to cancel out. So that gets me 25 minus 5, which equals 20. So that's what's in my denominator. And again, if I look at this rule of how multiplying by the conjugate always works, my a in this case was 5, so 5 squared is 25. And then the square root of 5 squared is, again, 5. And we got that 25 minus 5, which equals 20. Okay? So now I need to go ahead and look, can I simplify this down? So since I have this fraction, I have the whole numbers 20, 4, and 20 outside of my radicals, and I want to ask myself, what's the biggest, the greatest common factor of these three numbers? And the greatest common factor is 4. So I want to divide each term by 4. So 20 divided by 4 is 5. 4 times the square root of 5 divided by 4 is just the square root of 5. So 5 minus the square root of 5. And then 20 divided by 4 again is 5. So that would be that in simplest radical form, and simplifying that fraction down as well. All right, C, I have 1 plus the square root of 3 divided by 2 minus the square root of 3. In your notes, it has the cube root. Go ahead and cross that out because we're just going to be working with square roots. So again, I need to multiply by my conjugate. So I have 1 plus the square root of 3 over 2 minus the square root of 3. So I'm going to multiply by my conjugate in my denominator, which is 2 plus the square root of 3. Okay. And so now in my numerator, I have to FOIL it out because there's no other way to multiply this. So 1 times 2 is 2. 1 times the square root of 3 is the square root of 3. Plus 2 times the square root of 3. And then plus the square root of 9. My last two, the square root of 9 we know is 3. And then I'm working with that conjugate trick. So 2 squared is 4. And then the square root of 3 squared is going to be minus 3. So in my numerator, I now see that I have some like terms that I can combine. So I have 2 plus 3 is 5. And then radical 3 plus 2 times the square root of 3 gets me 3 radical 3. So I have 3 times the square root of 3 plus 5 divided by 4 minus 3, which in this case is 1. And dividing by 1, we know gets us our original answer. So my final solution, 3 times the square root of 3 plus 5, simplest radical form. So now last up we have dividing. So the quotient property of radicals, again, says if I'm dividing two radicals of the same index, I can write them as one single radical. So if I have something like the square root of 6 divided by the square root of 3, I can write that as 1. So I can write that as the square root of 6 divided by 3, and this we know 6 divided by 3 is 2. So I can divide just like that. So there's multiple different ways to divide radical expressions. Some people prefer to simplify the numerator and the denominator, see what they can cancel, and then rationalize if you need to. Some people prefer to use the quotient property and write them as 1. Some people prefer to rationalize right away. Again, they're all correct. So I'm going to show you a couple of different ways. So I have my first one, the square root of 25 divided by the square root of 75. So again, the quotient property tells me I can write this as one single fraction. So if I write that as one single fraction, and I want to simplify that down, I know that 25 over 75, the simplest fraction for that is 1 over 3. And then I can go ahead and split that up, kind of inverse of the quotient property. I can split those, so I get the square root of 1 over the square root of 3, and I know the square root of 1 is 1. So I have 1 over the square root of 3. Except the problem, again, is that I have that radical 3 in my denominator, and I can't have that. So then I would need to go ahead and rationalize. So times the square root of 3 on numerator and denominator. So that would then get me a final simplified answer of the square root of 3 over 3. Okay, so that again, that's the first method. I'm going to show you another way. So if I want to simplify down right away, the square root of 25 I know is 5. And the square root of 75 is going to be 5 times the square root of 3. So if I take a look, those 5s cancel, and that would get me 1 times the square root of 3. And then I get exactly what I got at the end. I would just need to make sure that I rationalize, but then I get the exact same solution. So there's another way to get that if you would like. And the very last way that some people like is they like to go ahead and rationalize right away. So if you go ahead and rationalize the denominator right away, you would be multiplying both by the square root of 75. So that would get me the square root of 1,875, all divided by 75. So then you need to go ahead and you need to find the biggest possible perfect square of 1,875. And it is a very, very big number. It is 625 times 3 divided by 75. And the square root of 625 is 25. So this would be 25 times the square root of 3 divided by 75. And when I simplify this fraction down, I get the square root of 3 over 3. So I just wanted to show you all three ways that you can go about solving dividing problems. I always like to rewrite them as one fraction and then simplify them from there. So the very first way that you saw, but I just want to show you those other two ways as well. All right, so then going ahead to B, I have the square root of 20 divided by 4 times the square root of 5. So if I look at my two whole numbers, this is like 1 over 4 times the square root of 20 divided by 5, if I write that inside of one radical. The square root of 20 over 5, 20 divided by 5 is 4, so this is like 1/4 times the square root of 4. And we know that the square root of 4 is equal to 2. So this is like 1/4 times 2, which is 2 over 4, which as a simplified fraction is equal to 1/2. You could also, if you wanted to do the simplifying right away method, the square root of 20 becomes 2 radical 5 over 4 radical 5. Those radical 5s cancel out, and then you also get 1/2. Again, doesn't matter to me which way that you'd want to do it. C, I have 3 plus the square root of 3 over 2 times the square root of 25. This one, since I have a expression in my numerator, I'm adding two terms together. It is a good idea to look and see, can you simplify the numerator, can you simplify the denominator? So I take a look, I have the square root of 25, I know is 5, 2 times 5 is 10. So I get 3 plus the square root of 3 divided by 10. And then I ask myself, can I simplify that down any further? And the answer is no. There's nothing to divide. There's no, the GCF's already been looked at, it's already simplified down. It's the simplest fraction, it's simplest radical form, and so that's it. And you do not need to